Hello everyone. Welcome to Smart India Hackathon Designing Digital Solution program. My name is Sakshi Jamgaonkar. I am working with Persistent Systems as technical trainer. I have around 18 years of experience in training field and I have been working with Persistent since last 9 years. I mainly train on Java J2E technology, different scripting languages like Perl, Python, PHP, then machine learning, IoT, Arduino programming, Raspberry Pi programming, etc. In today's session, we will be discussing about Arduino programming. The entire session is been divided into two modules. In the first module, mainly we will be discussing about introduction to Arduino, understanding what is Arduino, different boards that are available under Arduino family. Then we will talk about a specific board, Arduino Uno. Then we'll get into the details about Arduino hardware and then talking about introduction to Arduino programming. And then eventually in the subsequent second module, we will discuss about very interesting demonstrations using Arduino, details about Arduino programming with connected lot of sensors to it. And then I will be talking about one of the online Arduino simulator that is available called as Tinkercad. Okay then, let's get started. Alright, let's talk about agenda of this first module. We will learn about what is Arduino, Arduino boards, Arduino hardware, Arduino programming in detail, Arduino digital read, digital write. Let's understand what is Arduino serial communication supported. Let's understand Arduino analog read, analog write and PWM, that is pulse width modulation. Let us define first what is Arduino. Arduino is an open source prototyping platform. We have defined a prototype here, kind of a POC, created by Massimo Banzi, made in Italy. Based on easy to use hardware and software, Arduino boards are able to read the inputs like light on sensor, a finger on button or a Twitter message and turn it into an output like activating a motor or turning on an LED as an example, or publishing something online, etc. You can tell your board what to do by sending a set of instructions to this microcontroller on the board. To do so, you use the Arduino programming, which is based on wiring, and the Arduino software that is based on processing. So, these are the two major aspects about the Arduino programming, wiring part and the Arduino software based on processing. Now see, the board is having a history. The creator of this board came from university wherein he was already working on a project based on wiring and processing. So if you dig out into history of Arduino, you will be able to see the wiring project on which Arduino programming language is based and the software IDE. The software IDE that we are going to use is based on the processing of project. In all, Arduino is an open source prototyping platform. That is what you have to remember. Typical Arduino board look like this as shown in this diagram. Wouldn't be interesting to see the actual hardware so that you are connected to what we are trying to learn here. So let's quickly have a look at one insight on the hardware board of Arduino Uno. This is a Arduino Uno board that we are talking about, and this is a board that we will be talking about in detail. So let's come back to the slide first and then we'll try and understand each and every component available on this board. Arduino has specialization of prototyping. Certain commercial products also claim to use Arduino like the products like Fitbit, Pebble. These are the smart watches. However, Arduino is majorly used for prototyping only. One more area wherein we can talk about Arduino usage is Internet of Things projects. These are the three common elements as highlighted in the diagram. Typically in IoT, we will talk about the very first component as any sensors connected to any of the sensor node. Then secondly, we will talk about any protocol which will talk about the communication that has to happen from the data sensed from the sensor, and then ultimately sending the data to some server side cloud platform. So where does the Arduino Uno fit here? Looking at this IoT architecture, a typical IoT architecture is what I can highlight here. On this side, I am talking about Internet of Things, which are also referred as nodes. At this level, we can talk about, here the Arduino would talk about as the node to which the lot of sensors could be connected, which will have a capability of sensing the data, and that data can be communicated to a middle gateway. So at a gateway level, you can think of another Arduino board or a Raspberry Pi or many other boards in the IoT field. The communication between this sensor node Arduino to that of the gateway may happen through some kind of a protocol which is called as a short range protocol. Then talking about from the segregated data going from a gateway to a server side like IBM Watson platform may happen over a long range protocol like GPRS, MQTT, CoAP, etc. In this moment, the point of interest for us is this Arduino getting fit into the node section where Arduino is being used very widely. That's one of the typical use that I wanted to highlight at this stage. Natural question would be, why use Arduino? If I say it is used majorly for prototyping purpose, then there must be some reason behind it, right? Majorly the reason I could highlight here at this moment is it is inexpensive. Here are some of the reasons. The first one, the primary reason is it is inexpensive. The cost of this board in the local market is approximately INR 450. So the board that you will be using for prototyping, you have enough probability that you can goof off with this board. One of the fins may get burned out of your operation on the Arduino board, or if you did something wrong on the board. Even if you went wrong there, it is not very tedious or it is not impossible to just replace the small microcontroller IC chip or any small components on the Arduino board. You get it for a very small amount. So that's the beauty of this board. It is not very heavy on your pocket as compared to other boards that you can think of. The second point that we can highlight here is it is cross-platform. The software part of Arduino, that is Integrated Development Environment, IDE, that comes for it is written in Java. So if you are working on that IDE and working on the cross-platform, like some of you might be working on Windows, some of you might be working on Linux or Mac machine, they will not find any differences in the way the board is working. Many microcontrollers come with software which is not cross-platform. So this is another advantage. The third feature that we can talk about here is it is open source and extensible software. This is a major advantage of Arduino. So in the community out there, there are forums, there are FAQs, there is a support, Lots of it, and you can also change the work on the IDE. You can modify the libraries. You can contribute your own libraries. All that sort of stuff happens with Arduino. Not only this, it is also open source and extensible in terms of hardware. What does that mean? The board that you see for Arduino, the one that I showed you, you can take a breadboard additionally. I will be introducing you to the breadboard in some time. You can modify the circuit on this breadboard. You can load another firmware inside your existing Arduino board and then start using the new circuit. So that's how open source hardware and its compatibility is there. The plans of Arduino boards are published under a Creative Commons license, so experienced circuit designers can make their own version of the module, extending it and improving it. So all in all, it is a simple programming environment. When I will be showing you the IDE, you will find that it is really a very simple programming language for writing the programs. People knowing C, C++ programming language will not have hard time understanding Arduino programming. It is not like assembly language where you are writing some commands and you are not sure of what you are writing. It is very simple. It is like a day-to-day programming language that you talk about. The text of Arduino Getting Started Guide is a licensed copy under a Creative Commons Attribution Share Alike 3.0 license. Code samples in the guide are released into the public domain. So all readily sample examples are available as a best documentation we can find for Arduino. Here is the official site highlighted, www.arduino.cc. Whenever you are working on Arduino, tons of information will be available here. Now understand one thing, these development boards, these are essentially first developed for educating children or elders, right, who did not have an access to electronic devices and computers. They were created so that you can play around with it, create the circuits for projects all on your own, and that's why these hobbyists and enthusiasts use these kind of boards the most. That's what, or that's the scenario where Arduino came from. So these are all the reasons that make Arduino platform very famous for start prototyping. Now here I am introducing number of Arduino boards that are there in the market. At the entry level, there are Arduino Uno, Genuino Uno board. This is the one that we will be learning today, Arduino Uno. We are at the entry level prototyping platform hardware. What else do we have then? Arduino Pro Mini, Arduino Nano. All these are entry level boards. There are some boards that comes with enhanced features like Arduino Mega, having more number of pins and many more things. Arduino Zero, Arduino Duo are couple of more examples here under this category. When you talk about Internet of Things, IoT in particular, Arduino Yun comes as a very popular platform board. It has a built-in Wi-Fi on the board, which is not there in case of your entry-level Arduino Uno board that I mentioned earlier. There are some wearable devices as well. For example, for smart hand gloves, smart jackets, you get the wearable boards. Here you have a Arduino Gemma, Arduino LilyPad. These are all circular in shape. They are very small and very flexible. You can actually sew it on the fabric of gloves and jackets to sense some data. Arduino also used in 3D printing, that is called as Materia 101. The yellow ones that are highlighted here, all with the yellow colors, they are the shields. At entry level, you have Arduino motor shield as highlighted. At enhanced feature, you have Arduino photo shield. For IoT, you have Ethernet shield, GSM shield, etc. What these shields do? They add extra capabilities to your Arduino boards. You just have to stack the shield on the top of the Arduino board and extend the functionality of an Arduino board. These are the products available in Arduino family. All the product details can be found at the official site of Arduino CC as highlighted here. So, these are the different types of Arduino boards in the family of Arduino. You can think of Arduino Uno, the one that we will be learning in detail. Then there is a Arduino Leonardo. The variable device that we were talking about here is this lily pad, a small round shaped board that can be stitched on your fabric of jacket. So, these are all the highlighted boards under the family of Arduino boards. Very common question, which board is best for me? Everything is documented here officially under the link provided. Having this official homepage of Arduino site, lot of information you can gather over here. This is the best documented Arduino Uno board that we can think of. Under the Arduino products, these are the lot of products that have been highlighted. With all the introduction and the documentation, will give you in detail the comparison also can be found here under the compare section. Here you can compare different boards and see, depending on the factors mentioned like processor, how much operating voltage is required, how much CPU speed is there, how many digital input output pins are there, how much EEPROM is there, how much static RAM, flash memory is supported, is there a USB UART communication support for a particular board. Depending on all these factors with the information given here, you can decide what is best for your prototyping or the application development. But for prototyping and the most documented board as such is Arduino Uno board. So, this is your Arduino Uno board. Let us talk about it in further details. This is a version 3 Arduino Uno board. Older boards may have some different topology, some buttons, some number of pins may vary. So, which may not be same for all the boards as you see here right now, but more or less the configuration remains the same. Let us talk about the individual elements on the board. The one that is highlighted right now here is USB port. This is the type B board, USB. USB cable, which would be of type A and B, would be required to plug in this board. You will be connecting the cable going from this port to the laptop. B will be on the Arduino board and A is connected to your laptop. I can highlight it here. The USB port highlighted on the diagram can be seen here in the actual hardware part. So, one end of the USB cable is connected to the Arduino board and the other end of the cable would be connected to my laptop or a desktop. For this, USB on your laptop desktop should be enabled. That is the first prerequisite. After connecting to laptop, LED on the Arduino board will turn on. Here what is happening is USB cable will do two things. The first one, the USB port supplied with the power to your board from the laptop with 5 volt. This standard USB connection supplies your board 5 voltage. So, powering of the board will happen through the USB cable drawing a 5 voltage from your laptop. That is the first usage through this USB port and the cable. The second one is you will actually burn the program written in the Arduino IDE onto the board through this USB port and via the USB cable. Then Arduino microcontroller will execute the code again and again, being a microcontroller. The next component that we can highlight here is the power jack. There is one more power jack at the bottom. If you do not want to connect the board to a laptop via USB cable, say typically in the field installed devices, you will not have laptop connected to the Arduino board. There you can have this battery connected or AC to DC adapter connected to get the proper power supply to this entire board. Operating voltage of this board remains 5 volt. See here the top pin highlighted. There are 0 to 13 pins. This is a digital section of your Arduino board. So, in all 14 digital pins on the Arduino Uno board. These are digital input output pins. What will you do with these pins? You may connect the sensors to these pins. If you take any sensor that will have VCC pin, ground pin, data pin in all 3 pins. Data pin will go to any one of these digital pins. Ground will be going to the ground pin that you can see here, either this ground or below we have 2 more grounds. And the VCC pin of your sensor will go to one of the VCC pin on the board. The VCC pin could be this 5 volt or 3.3 volt. Next comes the analog section. Here it is. There are A0 to A5 in all 6 analog pins on this Arduino Uno board. Next highlighted section is a power section on the board. This power section talks about V-in. You can also supply the power to the board via this V-pin and power up the board. Beside V-in pin, there are 2 grounds as highlighted here. These 2 ground pins are identical to that of GND pin that we already saw on the top section near the digital section. So, in all we have 3 total ground pins. Now, why do we require these 5 and 3.3 volt pins on the board? For any sensor to work, you need external power supply to it, as I already mentioned. Sensor will not work just by connecting one pin to the digital pin and the another pin just to a ground. It will be required to be powered up. That external power will be drawn from the Arduino board. For this, 5 volt and 3 volt pins will be used. Beside these, you have a reset pin which is identical to the reset button that you can see here on the top left corner as I am highlighting. If the program is running and you press the reset button, it will reset the program back from the beginning and starts the execution again. Same thing happens if you power the reset pin at the bottom. The functionality is same. Then there is a IO ref, as you can see here beside reset pin. This is input output reference sort of a thing. This pin provides input output range to the external shields that would be connected on the top of Arduino board. Similar AREF pin at the top beside the digital pin, AREF pin here is also there. This is the analog reference now. If analog signal on analog pins is varying between 0 to 5 volt, AREF can control that voltage upper magnitude. Now we are going to see the heart of this Arduino Uno board, which is on the top of this entire board. On the top of this highlighted black colored chip, you can see it's written ATmega 328P. This is a microcontroller chip. Arduino Uno is developed as a development board, but this ATmega 328P chip is the microcontroller. This is the heart of the entire board. This small chip has everything on it. Board provides just an interface to it. We did talk about the reset button already. Have a look at this silver button that you see here. It is a clock for the microcontroller. It is 16 megahertz crystal clock. That means on Arduino you can perform 16 million operations at the same time. That is its frequency, much lesser than the processors that we have nowadays. Then comes the ICSP pairs. Here is one pair and the second ICSP pair is on the top here besides the digital section. It is called as in-circuit serial programming, ICSP. There are two types of programs when you talk about Arduino. These are the two types of programs I want to talk about at this moment. One is the application code, something that you will be writing yourself for the functionality on the Arduino programming. Example, measuring the temperature through a temperature sensor and report that temperature. For this, you will be writing the code on Arduino. Second type of program is a firmware. Where is this firmware? Firmware goes in the flash memory of Arduino microcontroller. Firmware is the pre-programmed piece of software which comes with the chip. When I say I press that reset button that I showed you, program should start getting executed from the beginning is a functionality, the required functionality. Who told this microcontroller that this is the current required behavior? This entire behavior comes from the firmware, which is a low code level, supports the entire main functionality of your board. Functionality of like digital pin, functionality of your analog pin, functionality of AREF, IOREF pin that I showed you. Everything is coded already in this low level firmware program. It is inside that firmware code. If you need to change the behavior of this firmware, then you need these ICSP pins as I highlighted. There is one more black chip that you can see here. This controls the USB port. The top ICSP pin is used to control the chip firmware and right hand side ICSP pin section is used to control the firmware of your main controller chip. Then there is one built-in LED that you can see just below the pin number 13. This is a small LED that you can see that I am highlighting. The name of the LED is L, which is on board. This is attached to the pin number by default. None of the other pins have any such LED inbuilt connected. This LED lights up when you power on the board. Then couple of things I have to acquaint you on this entire board. One more thing that is very important is about this 0 and 1 number pin. There are RX and TX. LEDs are also named here. RX is for receiving, TX is for transmitting. So if you observe on this digital number 0 and 1, they are marked as RX and TX respectively. The serial communication happens over these pins. Now when you burn the program after connecting your board to the laptop or a desktop through the USB cable that I showed you, that time RX is receiving the program while uploading the program on the board. So RX has to be kept open. If any circuit is connected to these pins and at the same time you are trying to burn the program, you will get an error. So RX and TX should be kept open when you are loading the program on this Arduino Uno board. RX and TX LED will glow when program is running continuously. On digital pin section, some pins are normal like pin number 2, 4, 8, 12, 13, but some are with tilt sign 11, 10, 9, 6, 5, 3. Those are called as PWM pins, pulse width modulation pins. Digital pins will be used for connecting to your digital sensors, and analog tilt signed pins will be used to connect to the analog sensors. Simple categorization that we can understand here. Arduino is not capable of writing the analog output. We are talking about DC and not AC. All pins here give out the 5 volt, that is a square wave, wherein we can think of a low voltage is 0 and high voltage is 5. None of these pins are capable of sending out the analog signal. Analog signal is something that the sinusoidal wave that we can visualize. For getting that analog output, you need PWM. I will take you to the details of PWM further in the next topic coverage. Here right now on this PWM pin, you will be manipulating the square wave and in a way giving out the analog output, thereby running the analog devices which are analog in nature. So with this, we can quickly recap on the components that we looked at: USB plug-in, power jack. Here is your digital section having the RX and TX respectively on the 0 and 1. There is a ground. Then the heart of the entire board is this microcontroller chip. Analog section, in all there are 6 analog pins. The power section talks about V-in, 2 grounds, and the power pins as 5, 3.3 voltage, which we would be generally connecting to the sensor. Reset button, right now in the button here it is shown at this level. Here it is. This board might be a older version of Arduino Uno. In the current version that I highlighted, the button is on the left top corner. So just to summarize here, these are all the different components that we looked at on the Arduino board. So the microcontroller chip that I mentioned, Atmega 328P, Here are some specifications to highlight. It is a 8-bit processor. Operating voltage is 5 volt. Input voltage can be given as 5 to 7 volt through the power jack. However, 5 volt will be used for the operation of the board. There are in all 14 digital pins, as we already saw. There are 6 analog pins A0 to A5. 6 analog pins, 20 milliampere current is there at each pin. External circuit connected may expect the current between 20 to 40 milliampere. LED connected work on 22 to 28 milliampere approximately. So, if you connect LED directly, it will burn out with 40 milliampere flow through it. So, it restricts the current. In order to restrict that current, add the resistor in series to the LED. Make sure that when you are connecting the delicate device like LED, you should understand what is the DC output of the pin in terms of current. The DC current for 3.3 voltage pin is 50 milliampere. There is a flash memory of 32 KB only. Flash memory remains even when the power is off to your Arduino board. When you burn the program on the board, it is going to stay in the flash memory. So, only the code will keep running again and again, being this as a microcontroller functionality. The firmware code that we discussed just now occupies the 0.5 KB of this flash memory. It has a static RAM of just 2 KB. EEPROM, that is electrically erasable programmable read only memory, is just 1 KB. It is read only memory whose content can be erased and reprogrammed using a pulsed voltage. An EEPROM typically allows bytes to read, erased and rewritten individually. The clock speed of the board is 16 megahertz. There comes the two types of code that we already discussed. So, in all we can have an application code written ourselves and the board having its inbuilt firmware to give the basic functionality to the entire board. Finally, we are towards Arduino programming. Programming language that will be using with Arduino is simplified version of C. You will see C, C++ like syntax here. Arduino IDE that we will be using for the programming purpose is free. We need to install that on our machine. The programs that we will be writing on Arduino are called as sketches. They do not have any extensions. The file that you would create for writing your Arduino programming will not have any extension, and that is typically called as a sketch. Only one program runs at a time on your Arduino board. One program will be running until you burn a new program on it. Sketches are loaded in the flash memory. So, to get started with programming on this Arduino, we need this Arduino board. Get started with writing the program in the Arduino IDE, which would look like this. Once the program is written in your IDE, we will verify it and then burn it on the board. Let us quickly have a look at one sample demo here. I will connect the Arduino board and show you the IDE also. So, let me open the IDE first. Here we have this installed Arduino IDE, which you can get it from the official site of Arduino. So, this Arduino IDE is supported for Arduino, Genuino, Uno, and many more other boards also may be supported by this particular IDE. So the IDE typically looks like this. The programming aspect, we will be looking into it in detail, but for now, at least for you to see, you can have a look at the two methods are implemented, setup, and the second method is loop. Setup is your basic initialization when the program starts running. This is executed only once, and you put your main code here as the functionality implementation. This will run repetitively as a microcontroller that does that job of running the code repetitively. That's the code from this loop ready-made method. Now this IDE provides lot of menus at the top. As you see, there is a file, edit, sketch, tool, help, so on and so forth. Under the file, when you see, there are some ready-made examples already provided. So at the first level itself, if you want to quickly have a look at one of the ready-made sample, how is it coded? As the Arduino Uno has been coded with lot of ready-made examples, here you can have a look at under the basic category, lot of examples are already provided. Talking about digital signals, some of the ready-made examples already provided for analog, communication, for the display purpose, and many more external modules also which are connected here. For that also you get a ready-made example for a learning purpose. So to begin with, if I pick up the basics category, one of the basic example here, blink. I open that blink example readily given. It says it turns on the LED on for 1 second and then off for 1 second, and repetitively the job has to keep happening again and again. So this is a typical code that you can see. Under the setup, we have initialized something called as a pin mode. We will talk about this construct more in detail under the programming section. Here we have initialized the inbuilt LED built-in. I showed you there is a built-in LED by default which is connected to the pin number 13. So ideally you can even write 13 here. But as a convention, if it has been already been given by one of the constant, better you should be using the Arduino constants provided under the programming constructs. We have to initialize that pin mode of that 13 pin number where you have a LED connected as an output. The reason is I want to send out the voltage to this LED from the board so that the actuation of the LED should happen as on or off. Now how to make this particular LED connected on this pin as high or low, which will allow it to glow, that code goes in the loop section, for which I am using one of the ready-made methods called as digital write. Digital write typically will take two parameters. The first parameter is the pin number and what you want to send on it, the low or high. So I said send high. High is on the digital pin is 5 voltage. So with that digital write, automatically the LED that is connected to that inbuilt pin number 13 will glow. It turns on the LED. Then there is a predefined delay method providing a delay of 1000 millisecond, that's wait for a second, and then again make that LED built in. So what I should be writing after this delay? Digital write LED underscore built in, make it low na, so that you can see that power on and off of a LED after a second delay in between repetitively. Here it is, that's a sample code. So having this IDE program, now the program that you have written on your machine now, on your laptop, this program needs to be burned on the Arduino board. So let me take you to the hardware connection. Here is the other end of the USB cable that you can see. This is one end of the USB cable, that's a B type, and this A type I will connect it to the laptop. Just to quickly summarize here from the PPT slide as I had shown, this is your digital section where you have 13 pins along with ground here, A-ref. Then here is your analog section A0 to A6. Then you have this V-in, 2 grounds, 5 volt, 3.3, IO-ref, the couple of pins that we discussed. This is your heart of the microcontroller board, that is a microcontroller chip that we talked about. Here is your reset button at the top corner. This is your power jack, right? Then these were your ICSP pins sections that I discussed. And here we go with one of the inbuilt LED that you can see with the label L. Can you see that? And also there are RX and TX LEDs which are associated with your serial communication for a receiver 0 pin RX and for transmitting TX respectively on the pin number 1. So now I am going to connect the other end of the USB cable to my laptop. I am connecting it now. The moment I connect it, can you see that the LED is on and off? That could be the inbuilt LED, the firmware must be doing it, or is your program doing it. So right now if you upload, let me verify the program. What is that verify? What are the stages? We are going to talk about in detail in a minute. Hold on. So the below part here is a console where you will be able to see the entire execution, what is happening. The details are also getting executed because in the file preferences, I guess I must have enabled show the verbose output during the compilation. So verify is doing that compilation part, something similar to your C programming. So compilation first step is happening, and while doing so it's giving all the verbose details. But this is your blank . It's still doing, it's in under progress as highlighted here with the green bar. Alright, so after clicking on this tick mark, it has completed the verification and that is a compilation step. Now from my desktop or the laptop IDE where I have coded this blank sketch, the program is a small simple sketch having this setup and the loop method. I try to upload that. Now uploading will happen through what? The USB cable that you have connected from Arduino board to your laptop. The program will be uploaded on the board. So now the upload step is happening. The progress can be seen here. With the upload, linking is happening. Linking of your code that will go in the flash memory that we discussed. Done. Now what is that I have achieved? I kept the entire code blank. That means this is your blank sketch that you uploaded on the Arduino. So earlier the LED which was blinking now should be stopped because in the looping you are not coding anything and this is a current program. And what I already explained was Arduino will run only one program at a time. The previous program which was executing and putting on the LED repetitively now should be stopped because you have uploaded a new sketch now. So highlighting that, can you see that? I have switched the output to the hardware that I can display. The LED is off now. There is no LED glow. Now let's make it glow again. Since we already wrote a program for it, or we picked up the ready-made example with the pin mode setting and sending the digital write. Digital write is sending out the signal which will initialize or put on the LED on with the high or low signal that you are sending. So to make this entire program get uploaded on your Arduino board, first thing that I should do is verify. So I clicked on this. Done. Now let's upload the code. Now the uploading, I am repeating again. This is sending your entire program through the USB connection you have done between the Arduino board and the laptop. This entire program will be burnt into your flash memory. The moment it gets uploaded there and gets linked to your flash memory of the Arduino board, this void setup method will be executed for the first time, where you have initialized the LED built-in pin as an output. So the signal is going to go to that with the digital writing. Pin number 13 is a digital section, na? And that we have initialized to output. So now with this upload, with the latest sketch, my hardware output should be changed. LED should start glowing. Here it is, you can see that LED is glowing after the delay of 1000 millisecond. That's the program that we wrote. So currently this Arduino board application is having one sketch running repetitively. The setup happened only once. The pin mode was initialized wherein you configured that pin number 13 as an output pin. So only when I did digital write, it was sending the high signal to the LED and it was made on, or with the low it was made off. This is a simple sample demo that I can show you, wherein you can get connected to what all that we learned till now on this Arduino board. If this built-in LED is connected to the pin number 13, even we can add one external LED. So what is LED? I am not going to talk about much in detail about this, but as a hardware component, what I can show you is, this is your LED. The long leg that you can see here is called as anode, and the smaller leg is called as cathode. Anode, we will connect it to digital pin number 13 and the cathode should go to ground. That's the electronic circuitry basics. Only one care that you will have to take is, while connecting such external components on your Arduino board, make sure that you disconnect the USB power cable. Here it is, I am doing it now. The moment I will remove the USB cable, here it is, it stopped the execution. Now let me add the LED. The bigger leg, I will connect it to the digital section, pin number 13. Let me finish it first and then I will show. As you can see here, the bigger leg of LED I have connected to the pin number 13 and the cathode is connected to the ground section which is available in the digital section. Now let me connect back the USB other end of it to the USB port on my laptop. Isn't it interesting? You are sending a voltage output. So you are actuating one of the actuating component like a simple LED. So that's outputting the voltage from the board to that LED. LED is glowing with that high and putting it off with the low digital write that we did. Alright, so let's come back to what we were talking about. So this is a simple one example that I wanted to show you, which executed through your Arduino IDE that I wanted you to get familiar with. This is a programming language which is really simple to learn and apply. Almost the entire construct and the syntaxes that you can see much similar to your C++, and then we could connect to whatever the hardware details that we talked about till now, we could connect to that and see the actuation of the LED glowing. Let's continue here. Alright, we got the output, we saw the output. Here This is not any low level assembly language that we saw. All syntax is almost similar to your C programming language syntax that is supported for Arduino programming. So, it is a simplified version of C is what I can say. Does contain the comments, curly brackets, end of semicolon at the end. You might have hash include to include the external libraries that would be required. Data types that are supported are like your normal data values, char, int, float, array, string, etc. The operators are also supported, conventional operators like a common operators like arithmetic operators, plus, minus, divide, modulus, equality, equal, assignment operator, logical and or operator or not. Then you have and star as a reference and a dereference operators. Then you also have the flow controls like if, else, while, do while, switch, break, for. All these loops are also supported for this Arduino programming language construct, wherein you can start writing a logic as you are looking for. The time related functions are also inbuilt supported like delay, the one that we executed just now, or delay microseconds. The sketch that we wrote, I say this is a language that resembles C, C++ programming language. That means there must be a compiler also. But before we go to that entire flow, here we just to highlight is there is no concept of project or a workspace required. You can organize your code using the tabs. The typical sketch may have the include for adding the header files. You may declare some global variables, constants as required. And as I already showed you that the two methods that you will be implementing in your simple sketch would be setup, which is called only once to initialize the board, and void loop method, which is called in a loop to execute the main logic repetitively. So, here we have a compiler. The way sketch is compiled or built, the first step is pre-processing. It converts the Arduino C to something called as legal C. Thereafter, a compilation happens using compiler called as AVR GCC. That is a typical term AVR that we generally come across in case of microcontroller topology. After compiling, an object file, binary file is created. Thereafter, the linking happens, and finally, a hex file is created. This hex file IDE now connects to the board via the USB cable, as I already showed you. This hex file is written into the flash memory. Then Arduino bootloader loads the program and causes it to execute repetitively. This is how the typical entire writing of the program, compilation, linking to the system, linking it to your board, the hex file that is getting created and gets executed in the flash memory, right. Now, where is this hex file? To see the hex file location, you can go to the menu, select the preferences and check show verbose output during compilation. This I already showed you. If the verbose is already set on in the preferences menu, while doing this entire verify and compilation, it will show you the location also where the hex file got created. Somewhere it gives you the entire path also. Here it is. Typically, this would be the location where users under your username, app data, local, temporary folder, the hex file will be created with typical extensions that it may talk about. That is what the slide is trying to highlight you. And there in that specified location, you can actually search physically once you start playing with the Arduino. Once you burn the program in the Arduino board, the hex file that gets created is stored at this location. Now, since we are looking into the Arduino programming section, let us see the common functions and constants in Arduino. In order to write a program, we require to know all this. Most commonly used constructs are shown here on the screen. Under the constants, we have high, low. High is 5 volt, low is 0 volt. There is input, output, input pull-up constants. These are for setting the pin mode, as in the example we already executed. Here, when you set up the pin mode in the setup method, you had configured or initialized that as an output pin. So, only on the output pin the board was sending out the 5 voltage. Here the LED built in is another constant to highlight, pointing to the built in LED connected at the pin number 13, and we have set it to output mode. Similarly, you can set it in input mode or input pull-up mode. Various actuators, when put it on this pin like LED to give out the voltage to glow it, we set it to the output mode. Input mode will pull the voltage in, like for sensor to sense the input. Example, if the sensor is connected on the pin number 2, then set the pin number 2 as input. So, here we would be saying pin mode, the number 2 you can write, comma, set it as input. It is essential to declare this pin mode in the setup method. The reason being, there are some internal pull-up registers available on your microcontroller chip connected with the resistor to power up the supply internally. If you do not set the pin mode to output, say, and you write to give a high to that pin, register from the board comes automatically into picture. Imagine you are giving 5 voltage output, there is a register, then the LED on the top of it, so the voltage gets divided. Resistor comes in series to the LED, so the voltage gets divided. LED which is sitting on the top of that pin will light up, but with lesser brightness we can talk about. So, you should declare that this is the output mode, so that LED will get full voltage. So, you have digital pin mode, digital write method, digital read method. Related to the analog input output operations, you have an analog reference, you have an analog read to read the analog signals from the sensor, analog write in the form of pulse width modulation signal that you can send out to actuate the analog devices. To talk about some advanced input output operation, I have a pulse in method readily available, delay related, time related, these are the functions. And majorly, one more important aspect, you can perform the serial communication. Let us see them in the detail. Pin mode takes pin and mode as 2 argument. Configure the specified pin to behave either as an input or output. So, parameters would be as specified, pin number and the mode. Input means the pin is going to read a value from a sensor. Output means the pin is going to write a value to an actuator. Input pull-up used for writing the buttons or switches. Generally, this is useful, say typically when you have a switch button which is generally open. Whenever you press that button, the circuit gets closed. So, till the time it is open, there is some particular voltage that is drawn by that particular pin. So, this is used for writing the buttons or switches or anything normally open. When you only have to tie them to a ground, you do not need to run 5 voltage out of them. So, we have to configure them as input underscore pull up. We have a digital write and digital read methods. Digital read method reads the value from a specified digital pin, either high or low. So, how to read that? We will execute digital read the pin number, which will return me some integer value. How would I write the digital write? We have already seen that. Digital write the pin number, comma, the second argument is high or low constant. delay we already talked about. You may also start talking about including some additional library that would be required to initialize some external sensor actuations that is required. So, additional libraries might be required to be imported, to be included here in your sketch. As I already mentioned, very important aspect supported by Arduino is a serial communication. Serial is used for communication between the Arduino board and the computer or any other device for that matter. All Arduino boards have at least one serial port, also known as UART or USART serial. It communicates on the digital pins 0 RX and 1 as a TX for transmission, as well as with the computer via USB. Thus, if you use these functions, you cannot use the pin number 0 and 1 for digital input or output. Those should be kept free for the serial communication. You can use the Arduino environment's built-in serial monitor to communicate with an Arduino board. What is that serial built-in monitor? Coming back to the Arduino IDE here, you can check on the top right corner, you have a serial monitor supported here. Let me connect the board once again to my laptop through the USB cable. I am connecting the cable. I had to mention one more point before I go to the serial monitor. When a particular board is connected, two things that you will have to ensure. These two parts, board and port. Generally, this IDE supports many boards. So, if it has already picked up the one that you are talking about as Arduino Uno board, that is a correct one. Else, you will have to pick up the one that you want to have a support for this IDE programming to the board that you have. Then the second part is to be ensured before you actually start uploading the program on the board through this IDE, you ensure the port on which this communication is happening. Typically, they may get selected as COM5, COM6 or COM10. Since it has already been selected, my previous program demo that I showed you, the program was communicated properly via the USB cable. The program was burnt on the board and the actuation of LED was happening. So, these are the two things that you have to ensure is what I wanted to mention at this moment. Coming back to the serial monitor that we were talking about, the IDE will provide you this monitor where you should be able to read the serial input. Here it is. Whatever I enter here, that can be taken as a serial input, and whoever the another device sending a serial output, that can be displayed here in the display area of this whole serial monitor provided by your IDE. So, like that is a kind of a channel between your program here, the IDE, and your hardware Arduino board. So, through this channel, through your USB cable that is doing a communication, I can have a serial communication over that RX and TX pins on the board. So, now to do the programming on this serial communication, just have a note of this, and we will be using them in the couple of demos that we will see in the upcoming module separately. That time we will be using all these ready-made serial communication related functions. Like we will check if there is any serial data coming, then only we would start beginning reading the data, that is read the data, write the data. So, a lot of these serial communication related ready-made methods are available as highlighted. There is also the analog signal support on your Arduino board, as we have already seen. A0 to A5, 6 pins are there. Analog read method reads the value from a specified analog pin. Arduino board contains in all 6 channels, 10-bit analog to digital converter. This means that it will map input voltage between 0 to 5 volt into the integer values between 0 to 1023. So, syntax for reading the data from that pin is analog read, specify the pin number as an argument. Returning value would be the range between this 0 to 1023. Here is a reference link from your Arduino site with the analog read to learn about it more in detail. Analog write. Arduino Uno and most microcontrollers doesn't have the analog output pins directly. You need to buy a separate digital to analog converter, which in a way is trying to convert your square kind of a low and a high signal into a sinusoidal analog signal as shown in here typical diagram. So, this is PWM, pulse width modulation. On a pin in Arduino, a steady digital square wave is always generated going from 0 to 5 voltage on the digital pin we are talking about. Since some devices like DC motors etc. need the analog signal to run, we need the pulse width modulation to interface them with Arduino. What it does? The PWM tricks the Arduino and simulates a sine wave from your square wave. This is done using the pulse of varying duty cycle on the PWM pins, the tilt sign pins that we had mentioned. We will be looking at one example later on wherein the pulse width modulation sending output, which will give me a fading effect of LED. Had it been 0 or low or high, gave me just on or off effect on LED. But what if I want to see from a low to high intensity, the glowing of the LED that I want to see, we can send this analog pulse width modulation signal varying between 0 to 5 voltage and see that kind of effect. Data that you are sending is digital only, but in a way with the modulation simulation that Arduino is supporting, we are trying to convert that into PWM signal. All this what we are talking about is digital read, digital write, analog read, analog write, serial communication, and this pulse width modulation analog write part. We will be having interesting demos to see the entire concept in the next module. So, basically this PWM works to see the fading LED as PWM is a technique for getting the analog like behavior from the digital output by switching it off and on very fast and with different ratio between on and off time. Because of persistence of vision, we cannot see the time the LED was on or off, and because it happens so fast, we get a feeling that the LED is fading. This simulates a sine wave for you as highlighted here. So, converting the digital signal in a simulated analog signal as a sinusoidal wave here. So, with that we use analog write. Write the analog value, that is a PWM wave, to a pin number. Which all the pins that you should be able to use to send this PWM wave? Those pin numbers which are marked with the special tilt sign. Only on that you should be able to do the analog write. You need not call the pin mode to set this pin as the output before calling analog write. The analog write function has nothing to do with the analog pins or the analog read function. Now, as we before proceed on the next module where we are going to talk about couple of sensor connection, a quick input on electronic circuits and symbols. Though we will not touch upon this entire topic in detail, a quick highlight on this. We should be familiar with couple of symbols here, since we are talking about the hardware board to which the lot of hardware sensors will be connected. So, let us get familiar with these symbols. Diode, capacitor, inductor is shown like this. A resistor that will be added in series to your LED, for example, to limit the flow of current will be shown like this. This symbol is to show the DC voltage source, this is your AC voltage source, and this is your push button. Simple circuitry that I have to highlight: you have a LED, resistor connected in series, and the voltage is provided to it. So, the current flowing through this LED is limited or controlled through the resistor. With the electronic basics, that at least the terms that we should be familiar: voltage, that is a potential difference between the 2 points, it is measured in volt. Current, the rate at which the carries the current flow, measured in ampere. Resistance, obstacle to current flow, that is measured in ohms. just an intro on Ohm's law that states that current through a conductor between the 2 points is directly proportional to the voltage across 2 points. More specifically, Ohm's law states that R in this relation is constant independent of the current. So, we generally talk about the equation V is equal to IR. The different resistors that I will be using in connection to the series to control the flow of my current, we can use couple of resistors. Here is this typical resistor that I can show you, having the stripes on which giving you the actual value of resistor. So, these typical color stripes giving you the color coding and color formation with the actual value of that resistor. Let us say 470 ohm resistor, the one that I will be using in series to the LED to control the current flow. We will not go into the depth of how it is calculated, but typically this is a chart showing the calculation of a resistor value. And lastly, here as a part of electronic circuitry that you should be familiar with is the breadboard. The breadboard as shown here in the diagram will supplement adding more circuit to the Arduino board. Arduino board has limited pins, 14 or 13 digital pins, 6 analog pins, but if in case you want to connect more sensors, having more ground levels required, more power supply that I need to have the provision, you can do that entire external circuitry connection on the breadboard. Need to understand the topology of this board. On the top, here this top line colored in blue is a positive line. All the horizontal holes are in series, that means they are connected to each other. So, if I connect one 5-volt pin from my board here on this first hole, then all the remaining holes horizontally in a row, they carry 5 volt. Then one more upper line can be made as a ground line. On your Arduino board, we have already seen that there are only 3 ground pins. So, if you want to have more grounds required for your entire circuitry prototyping that you are building, you can get one ground connected here, then you have remaining all these pins serially connected with a negative ground. So, the entire line will become ground. So, this is one top row having both positive and negative, similar one row is repeated here. This is how it look like. The line that I was talking about, this line, so you get one ground, you get one supply, so they get multiplied here. These many pins you achieve in multiplication. Then as shown here in the diagram, there are these middle rows 1 and 2. Same topology is applied, but how? Come to the central row section. Here vertically the holes are in series. As shown here vertically, they are connected, they are series. But holes on the rows, they are not in series, they are not connected. So, here it is. So, any resistor if I will have to add, I will be adding something like this. In a horizontal one row, add a resistor like this. That is not in series. If you connect it vertically in this one section, then that will be a short, they are in series. Both these sections are not connected to each other. So, all said and done here is additional circuitry can be built on this particular Arduino board. So, the holes between the 2 column sections are not connected. So, we will be using this board in upcoming session for talking about interesting examples to carry on the Arduino programming, lot of sensors connections, all that we will do it by using this Arduino board as I highlighted. So, as in connection the entire Arduino board, adding the external components here on this board. We'll try and come up with simulating a kind of a prototyping with a lot of sensors that we will be covering in the next session. Alright, with this we have come to an end of our first module on overview of Arduino. Just to summarize the topics that we talked about: overview of Arduino, introduction to a lot of Arduino boards that are available under Arduino family, Arduino hardware details, then getting into Arduino programming basic constructs with the programming fundamentals like digital read, digital write, analog read, analog write, then what is that serial communication supported by Arduino programming. In the next session, we will be talking about Arduino programming in detail with a lot of sensors connected to your Arduino board, and also we will be discussing about one of the online Arduino simulator that is available called as Tinkercad. Here are some technical reference links for you. Hope you found this entire session interesting and useful. See you soon in the second module. Thank you everyone.